Assalamu alaikum. Today we will discuss about CPU, about a AVR CPU and how the things in it works. Now there is a simple CPU, not AVR. There are basically four components in it, which is ALU, which is called Arithmetic Logic Unit, and there are four registers are connected in that, which are basically A, B, C, and D. They just named it as A and B and C and D. They are just basically four registers. They are PC, which called program counter, and this is instruction decoder. Now we have a live example of how basically it works. Now here is a CPU. There are different components which we told earlier, and there is a memory connected to it, and there are this memory has different contents, and each of it contents has a different address, which you can see that we can say uh, the zero address has 31, one address has C4 value, two address has 26 value. So basically there are different values of different addresses of different contents. So now we will see how that works. Basically it is this working very simple, very basic. First it is saying that just take the value, but whatever the value basically on 17 address, just give it to the A value. Okay. Then it says that what address the A has, which the same address which the A has, basically is it become equivalent to B, and then the which whatever the value on the sixth address is basically give to A, and then after that there's a basically adding method A plus B, and then at the end and then it says that with the final result with A, just give it to the seventh address, which is here we can see the space is empty, the seventh address. So basically at the end, when we will have the content, we will have a value on the A address. So basically it will give to the seventh position. Now we will see how it works. Now we will first oh sorry, first we will I will explain how the components will work. uh, First there is ALU, which basically control the mathematical operations. There is an instruction decoder which basically tell the which address are you working about, and there is PC, PC which basically tell the what is the next address you will work out, and there are basically four registers A B registers for A B C and D. Now, if we'll run the program, it will work on the, we can say it will work on the zero position because the next position is zero. Now, program is running, and basically we just run the program at first address like zero, and its value 31 at is being written in the instruction decoder 31. And then it's basically we are saying at the input output position 17. Let's suppose we gave a ninth position, we give a ninth value in the 17 address, and then it will save to the database, and then it will give to A, because we are here, we are saving we are saving the content from the 17 address. So it will we will give it some value, let's suppose 9 value, we gave it a 17 position, and it will save to A, like that. Now after that we can see that the next position, which is B, and we are just making B equivalent to A. So the next will work out, and the first position, and which is basically second position, and one address C4, it will then come here in the instruction decoder, and then the PC becomes 2, because PC always tells the next address. So the next address is 2, so PC become the value here is become 2. Now because there is we are working on the command, we are working on that we have to make A equivalent to B. So the same address 9 which was on the A, now it will now come to B. Now we will now work on the third position and the third address 36 now. Now let's suppose we gave the third command which are saying basically the 6 address, whatever the values on 6 address, just save it to the A. And now we just save it to the A, which is 5. Now when we will come to fourth step, which is basically A plus B, then the adder become activated, and then we will add A plus B. And then at the last we are saying that just the position the after the addition which value have A, whatever the value which will be A, so that value will be then go to the 7th address, which is our final answer, EH. So basically it's a very simple working of how Stewart CPU works inside the computer. Now we will now go to the next part of our assignment, which is basically we have just to tell the how data is stored in the AVR CPU. So there the components as we told earlier, the PC, ALU, instruction decoder. And then it is a basically a simple program example to just show the how it is stored in the AVR CPU. It is basically LDI, a command, and when we write here LDI, basically the command is invoked here, and RD means register, and D means the destination of the register which we want to save that value, store that value. So example is written LDI R16. LDI is the command. R16 means R16 comma 53. That means the 53 value will be stored at the 16th address or 16th position of the register. Like in the 16th address or in the 16th position of register, R53 value is stored here. So it is a very simple step, a simple concept that how data is stored in the AVR CPU. So thank you. Allah Hafiz.